Now comes an important topic of the kinetic theory of gases. So first of all, we will write down the postulates of this theory, what this theory basically tells, and then we'll try to understand the implications of that. So the first postulate is that the gaseous particles are small in size and identical. And by the gaseous particles, we mean the atoms or the molecules, either of them. The second postulate states that the volume of these gaseous particles is very small, right, as compared to the space between them. So basically, these gaseous particles, if we write in other words, are being referred to as what we call point masses. Now let's try to understand this point a bit. Basically, we are saying that the gaseous particles which exist, about which we are studying, are very small in size, and they are so small that the volume that they occupy can be neglected as compared to the volume of the container in which they have been kept. Like if you look at this figure, we can say that if this is molecule A and this is molecule B, their sizes are, say, of the order of 10 to the power minus 10, and the dimensions of the box are of the order of, say, 10 to the power 5. So their sizes are almost negligible as compared to the size of the container. So this is what is called as being a point mass. So we are considering them to be point masses. Another assumption or postulate is that there is no force of attraction between the particles, and their motion is completely random. It is not a predefined motion that they would always move in a straight line, like is evident in the figure as well. Any particle may be moving in any direction. They do not have a fixed direction or a fixed pattern of motion. Like all of them are not like moving in a particular direction. It is completely random. A particle may be moving like this, like this, like this. Some may be stationary at a particular point. Anything may happen. So it's completely random. And due to this random motion, due to this randomness, the particles collide with each other. Right, it is quite obvious and evident as well in the figure that if all the particles start moving in any direction they want, they would definitely collide with each other. So they do collide. However, these collisions are what we call as elastic collisions. Now let's see what we mean by elastic collisions. When we talk about an elastic collision between two particles, it basically means that the particles on colliding do not lose any energy. There is no loss of energy during an elastic collision. Then the next postulate is that the pressure exerted by the particles is because of their collisions with the container or with the volume in which they have been kept, or let's say with the walls of the container. So when the particles are moving randomly, they would definitely collide with the wall as well, and those collisions are the cause of the pressure that we measure as pressure of the gas. The next postulate is that the kinetic energy, let's call it Ke, of the particles is directly proportional to the temperature of the gas. So higher the temperature of the gas, higher would be the kinetic energy possessed by the particles. That is, with more average speed would they be able to move. So these are all the postulates of the kinetic theory of gases. These have a number of implications, such as the kinetic gas equation, which we will be studying next.